pleased to have Doris Möncke, Associate Professor of Glass Science and Engineering. It's very appropriate we have Doris to start out our schedule this semester because 2022 is the International Year of Glass. And Doris's talk is entitled The History of Glass Science and Technology. So thank you, Doris.
Yeah, thank you for the introduction. Now I have to... The share screen thing is different than before.
No.
I don't know, my computer just slowed down, but I hope this is... I hope you are now all seeing the screen.
It says Doris Möncke.
Okay, so I tried to compress like 4,000 years of glass making into 30 minutes, and that can't really work. So I apologize for all the things I'm skipping over. Also, I'm a professor for glass science and engineering, so my background is chemistry and not archaeology. But I have lived 4 years in Athens, Greece, and I've worked there at the National Hellenic Research Foundation studying modern glasses. But there were so many ancient glass samples from late Bronze Age, Mycenae, and to Roman glass pieces. And we had the cooperation with Nikos Zacharias, who is the head of the Department of Archaeometry of the University of the Peloponnese. And he gave me some Roman glass samples and Mycenaean glass samples to study with infrared and Raman spectroscopy. And the very first spectra I took of this blue fragment looked exactly like the spectrum of a low alkali borosilicate glass like Pyrex, which has a much higher melting temperature. And that couldn't be true. And it took us about 6 years to find out what was happening, that there is a surface borosilicate layer because this piece was probably gilded at some point and the goldsmith used borax at that time in the fusion process, and we have a reaction on the surface. So later I went back to Germany, and the glass community, where the history community in Germany is very different from Greece. So in Greece and UK, you have chairs for archaeometry at the universities looking into the science and the structure of ancient material. In Germany, we don't have that, but there is a very lively community of glass enthusiasts, laymen and laywomen who just want to know about the history of their town that was founded by a glass workshop, archaeologists and scientists who work with the different materials, and they're sharing all what they know about glasses in little meetings. And right now I have 2 kilograms of medieval glass shards, the red ones you see here, in my lab, and we try to understand how copper in different redox states changes the formability and the melting behavior of these glasses. There's a similar project, I don't have the glass sample, but where we want to look into the function of iron 2+ versus iron 3+, how that changes the viscosity and the melting behavior. And that's something we can do here in Alfred, where we have a glass art department and the glass science engineering department, where we can merge the science and the glass working and melting. And we have gas-fired furnaces, which mimic the old wood-fired furnaces much better than the modern electric furnaces. So with this background, I want to get to glass. And before talking about glass making, so the use of glass, that's one of the oldest used materials by humankind. So already in the Stone Age, glass arrow tips, glass knives have been used widely. And that's one of the typical properties of glass, is that when it breaks, it has these shell-like breaks and very sharp edges, which most of you probably have experienced by accident. And you see here in the center of the slide, SEM scanning action microscope images of an obsidian scalpel, and on the right a steel scalpel. And you see how smooth the edges of the obsidian glass are. There's anecdotal evidence of using it in surgery, but of course glass is a little too brittle to be comfortable in using that and having the tip break off. So very briefly, just what makes glass such an interesting material and why we have the International Year of Glass and the Glass Age and everything is, so glass is just another state of matter, and we are all familiar with solid, liquid and gases. And now glass is is a solid, but it has the structure of a frozen in liquid. Even so, we are not using that definition anymore because there are cold ways of making glass, so we don't have to go through the melt, through the liquid, but it has this disordered structure. And it also has a transformation and relaxation range, and that makes it so versatile in the way we can form it in all kinds of things. So just here, this graph shows how a crystal changes its volume as you increase the temperature, very slightly. And then suddenly at the melting temperature, the volume jumps and we are getting into the melt. Other properties do the same thing, enthalpy and so on. If you cool the melt and you get to the crystallization temperature, it crystallizes and we are back in the crystal. But if you undercool the melt, you can get to a disordered solid where the viscosity increases until the atoms can't move anymore. And that's where the slope of the change in property changes. So we get to a formable melt to a solid glass. And that allows us to work with glasses the way we do, like fiber drawing, blowing all kinds of forms, pressing glass in different forms. So we can all of this while it's still in the kind of liquid state, and then it's form stable at low temperatures. One other thing, pure sand, that's the main component of glasses, and that's why we are just talking before the meeting started about a 2,000-year-old Roman glass bowl found in the Netherlands. So it's still there after 2,000 years. It hasn't corroded. And that's because of the high silica content. But silica itself melts above 1700 degrees Celsius, or in order to steer the melt and have bubbles escape, you have to be higher than 2000 degrees. You can't reach that with wood-fired furnaces. Even today, we don't have that many crucible materials that can withstand those temperatures. So that wouldn't have worked. But if you add sodium oxide, calcium oxide to sand, then you get a eutectic that melts at much, much lower temperatures. And interestingly, the composition was 74% silicium oxide, and then the rest sodium oxide, calcium, potassium oxide. That's a eutectic, so it has very low melting temperatures, and it's very easy to undercool it and to freeze it. And this is this composition the Egyptians used 4,000 years ago, and the Romans used, the medieval glassmakers used, and we are still using today in modern day window glass or container glasses. I'm not going through those reactions, but it's all about these low melting of the sodium carbonate and lime that allows the really otherwise hard to react sand, pure silica, to dissolve and become part of the glass. For most of the last millennia, it was sand and plant ash used for melting glass. For quite a while, Egyptian and Roman glassmakers, they had access to trona, that's mineral soda of very high quality. So just by mixing soda with sand, they got to a pretty good glass composition. There were seashells in the sand, so they already had lime in their glasses. Later, medieval times, when they were using trees, the ash from trees, and not sea sand, but inner landlocked quartz, they had to add lime, otherwise the glass wasn't stable enough over time and corroded really quickly. Now, the very first glasses, that's a bit hard to say because we have a lot of glazes that are older than the first bull glasses. And the composition of lots of glazes are very similar to actual glasses, but they needed a support, like that were glazes on rocks, glazes on ceramics. And then there's the Egyptian faience, where you have an outer vitreous layer, but inside it's more in unreacted ceramic parts, so sand and sodium lime carbonates. And sometimes these beads, if they have been fired for a long time and at high enough temperatures, they might be vitreous inside, and some are very crystalline inside. So one theory of glass invention, glass melting, is that it was connected to ceramics and pottery, that they just overfired because they already were familiar with the material, and so they should know how to work it. But the big problem is that few pottery kilns can reach the temperatures needed for real glass making. But who knows, those we are working with high temperatures, that were the metallurgists. We are talking about the Bronze Age. So they had to get copper, metallic copper from copper silicate ore. And the base product of that process that are silicate-rich copper slags. And many of these are actually vitreous, still today, a lot of iron ore and copper ore processes. And often really nicely colored due to the copper transition metal ion. And for a very long time, all the glasses are deeply colored. So we don't really have transparent glasses at that time. And they were used like gems, and they had the value of gems. And in all texts, there is a distinction between lapis lazuli from the fire, from the kilns, and lapis lazuli from the mountains. So the natural gems and the artificial gems, they were valued very similar. And I think it was also very hard to make them, and you needed the gods' help and all kinds of random things to happen at the same time to get to the glasses. And all glass manufacture was really located near the palace and the monopoly of the rulers. And the oldest real glass furnace that came later, that was the 14th century BC in Egypt. And the archaeologists are very, very strict when they say, oh, we actually have a furnace. So you have to have the crucibles and the furnace and the glass waste and the glass in the crucible and the product. So there's, and the old findings of glass pieces that are older than the furnace, that is in Mesopotamia, and some findings in Egypt, which are in the style of Mesopotamians. So they were likely gifts and imports. So now we think the origin of glassmaking was not Egypt, but somewhere in Mesopotamia. The problem there, in the original part, that's here the blue circle, they did not burn their tiles. They had no forest. They did not have a word for slag. So they weren't doing the high temperature processes. But the Mesopotamian Empire was huge, and they conquered a lot of other places, including what's here, the bluish area, the Hittites. And so that might actually be the origin of glass making. And then once recognized, it was connected to the rulers, who then gave it as a gift to the Egyptians. And the Egyptians really started the first golden age of glass making. As I said before, the glasses were not yet transparent and colorless. So we have a lot of blue, that's cobalt blue on these examples. Also opacifiers, calcium antimonates that didn't dissolve and give the white inlay in the eye, for example, here. The Mesopotamians still did their own glass working in a different style, and there was a lot of distinguished style in Mycenae. So they were great fans of cobalt blue beads, also of copper blue beads. They didn't do any amphoras like the Egyptians and the Mesopotamians. There's only one find, and that's likely an import. And there are no furnaces found in Mycenae, like this one. That's the Egyptian furnace I mentioned before. So they found enough evidence on how the structure of the furnace was to rebuild one, and that could reach 1100 degrees Celsius. Glassmaking might need longer at relatively low temperatures, like a full week. But they also found crucibles, big crucibles with glass still inside. And they found a shipwreck in front of the Turkish coast that had glass ingots in it that fit exactly into the crucibles from the geometry, and also the composition of the crucible glass and these ingots matched exactly. So these ingots, that's primary glass melting. You get this, the first raw glass, and then you are selling that. And the Mycenaeans definitely used that for their glass beads. So they had smaller secondary glass melting furnaces, and we just have no archaeological evidence of those. While the Mesopotamians did their own glass melting with a different composition. And the Mycenaeans perhaps had their own, but that's not, because we don't have the furnaces, we are not sure about that. So there's a lot of the Mycenaean glass beads. They had been covered by gold sheet, and we think the fusion of the gold with the glass was done with the help of borax. And in Anatolia, there's a lot of borax mining and gold mining. So the goldsmith at that time probably had access to both. This is one of those little glass bead furnaces. Actually, that's the Roman Villa Borg in Germany is a place where they try to remake traditional Roman glass furnaces only with the material used available to the Romans. And this is the little glass bead furnace. And you can melt from raw materials little glass beads in this furnace, but it's easier to use it like flame working and just remelting glass pieces. This can be built within a day, and it can, so they had several of those furnaces and they left them stand for a couple of years, and the corrosion is really, really heavy even after just a couple of years. And then imagine 10 years, 100 years, 3,000 years, and there will be no evidence, and the soil isn't burned enough to give evidence to the archaeologists in 1,000 years. So there is no surprise that we don't see evidence for glass melting in Mycenae. Now I want to continue a little bit more on changes in glass forming technology. So the oldest vessels out of glass, they were actually made by having little glass pieces and putting them into a mold and then firing the whole thing and getting a bulk glass. And then the hole was drilled into this bulk glass afterwards. Apparently Egyptians and later the Romans, they were really good in drilling and working glass mechanically with a drill. Of course, these vessels are very small and the content was very small, so you couldn't put much into it, but it was used, for example, for precious oils, medicine, cosmetics. And then the first revolution was the going from drilling to the sand core technique. So it should be named clay core technique because clay was the better working material for those experimentalists who try to redo those techniques. So you have your clay form on a stick and then you wrap the liquid glass around it. You can still fire it in the fire to smooth it, to homogenize the bends. And then you added later those decorative elements while the melt was still liquid enough. Often Naples yellow, that's a lead antimonate, microcrystalline, so it's not transparent. And the blue color here, it's often cobalt in a more semi-transparent glass base. And then you could crumble the clay and the sand and you get a hollow vessel. Then the late Bronze Age up to 1600 BCE, slowly the Mycenaean Empire declined. There was a lot of wars and seafaring pirates, and so there is a decline in a lot of these high cultures. And Mycenae totally lost the art of glass making, and but the Phoenicians, they kept the art, and there was now a new glass center in Phoenicia, and that later started the new glass melting in antique Greece. Around 1800 BC, the first transparent glasses occur, and we have the first written evidence in cuneiform between 600 and 700 BCE from an Assyrian library. And it says, take 60 parts sand, 180 parts ash from sea plants, 5 parts chalk, and you will get a glass. It also says a lot about the right phase of the moon and how to purify yourself and what kind of wood you should use. And we see that up to year 1000 our time, when Theophilus writes about working glass and apparently feeding the blood of a goat that has been fed by certain herbs is important to work glasses better. Still, 2000 years later than this. So here's one of these clear colorless glass examples. So archaeologists call that naturally colored green because that's the iron impurities from the sand. And it's very hard to get rid of these impurities and to get high purity raw materials that don't turn green. On the right, you see a mold for forming glass. So that mold has been found at a workshop in Olympia next to the temple with the statue of Zeus, which was one of the 7th wonder of the antique world. So this god had the dress made out of glass, and while the statue is lost, the dress is lost, the mold that was used for making the glass dress, that has been recovered there. And now these bowls, I mean, they look so modern in a way, but they are still, first, 2nd century BCE. And they're all made by putting glass pieces together from a primary melt and then letting it sag over a preform to form the bowl shape. This is from this Roman furnace project where they tried with the now Roman furnaces to recreate the old art forms, and here they were making those mosaic bowls. The slightly different technique, reticella bowls, by twisting 2 different colored glass into fiber and then wrapping this fiber around the preform, molding it usually with wet wood, and getting to this really nice forms. But yeah, they learned at that time also to take care with the raw materials and to have pretty clear glasses. So this is one piece, you see the front and the back of it. It's almost 60 centimeter in height. It's made out of several different glass pieces that were then fused together after forming. And so the central axis isn't exactly in the center because the foot was attached separately later and the handles were added later. But it's, I mean, yeah, quite impressive at a time where they didn't have the art of glass blowing, and they still had to do everything by forming and pressing. Here's some Egyptian glass amulets from that time, mosaics. And again, it's just putting the glass pieces from a first made together. And I don't know, we did that as kids in kindergarten, have these little plastic things, fusing them together and putting them in the stove. So they did that with glass. And they were kind of effective too. So they were using long glass rods at the time for this lotus flower, for example, and then cutting off different slabs. So they had 20 times the same motive just by one fusion process. And in a way, we are still using this technique for hollow core fibers, where we stack capillaries and get a special design, and then we fuse it and get a homogeneous glass matrix as the capillars melt together. And then we enter now the 2nd golden age of glassmaking. That's in the Roman Empire. The composition of the glasses is still very much the same as in Egypt, Mesopotamia, Phoenician glassmaking. 74% silica oxide. However, the sodium to calcium distribution is very similar in Roman times. So that's the red circle here in this little ternary diagram. While other times, other areas, you get much more variation between sodium, calcium, and potassium oxide. So they were very strict, always adhering to the same recipe, and it didn't matter if they made the glasses somewhere in Germany or in Italy or in Greece. The recipe was always very similar. But you see below what beautiful objects they could make. So the cameo glass on the left in the center, the cage cup. And then they started with the first windows. They weren't exactly comparable to our windows, so you couldn't really see much what's happening on the other side, but it let light into the building and kept the wind out. So that was the main function. And they were still using the same colorants as the Egyptians, cobalt blue, copper red, and also lead antimonate as a yellow decorative agent. These cage cups, I said before, so the Romans were also really, really good in drilling. This is probably used as oil lamps rather than drinking cups. And so from a very thick preform or from a double walled pressed preform, and then everything was drilled out. And you see that the different colors, so the outer layer pressed into form was a different glass with a different color than the inner layer. On the top right, you see a remake. Joseph Welzel was an artist in Europe, while the Corning Museum has a replicate made by a dentist who knows how to drill. And so there's still some discussions on how exactly they were made. And there are a lot of artists trying to redo those. Here's some idea of how through pressing different glass colors in a preform, you can get to the cameo base. There was also some fine polishing afterwards for the little details. And now we get to the next invention. That's really the blowpipe is changing everything. And while in Egypt, the glasses were next to the palaces, also Mycenae, and very valuable commodities, gifts from the kings. With the Roman time, they were becoming a normal commodity. And with the advent of glass blowing, mass production really sets in. But the prerequisite is the entering the Iron Age and having form-stable iron pipes that can be rotated without hurting the lips, without breaking, without losing the form. What bronze pipes couldn't do that. And so with the Romans, they also really started mass production, and they were blowing into preforms, like shown here, made out of terracotta with a graphite layer, so to unstick the glasses. And so more and more households now had drinking cups, had windows. And actually, this is a process we are still using in automated bottle processes or pickle jars. Only it's all automated. We use compressed air, not the blowpipe anymore. But the glass manufacturer till the end of the 19th century, we are still doing the old-fashioned manual blowing. And now we get to these modern blown mosaic bowls, where we have the more abstract distortion of the mosaics. And in the Romans, of course, they were all over the Mediterranean and up to England and in Germany. So they were selling glass pieces all over. They knew how to wrap them. And they also, here on the right is a funerary urn, so big pieces. They knew how to play with the color. And they already used recycling quite extensively. So they were shipping barrels of glass shards over the Mediterranean. They also had the little glass pieces that they didn't want to break, and they knew how to wrap them so they wouldn't break. But there's another shipwreck, this time the Julia Felix, where there was a large wooden barrel, 1.5 meters high almost, with thousands and thousands of broken glass vessel fragments. They're kind of sorted into colored and not colored, and they're old invoices, so that colored glass was only half the price than colorless glass. And of course, if you have colorless shards, you know that you will get a high quality colorless glass if you remake those. You need less energy, you have a better quality, less bubbles, less inhomogeneities. So recycling was already great at that time. And then, with the decline of the Roman Empire, the glassmakers went to East Rome, so the Byzantine Empire, and from there they came back to Venice. And with a lot of knowledge lost and the access to the mineral trona in Egypt lost, medieval glass melting now had to use forest plant ash for glass melting. And here on the left, it's a picture of European medieval glass forest workshop. Here's an excavation in central Germany. This is actually a window fabrication piece. So they had the glass melting furnace. They had 2 annealing layers to carefully cool the glass down without shattering. And they had 2 stretching layers. And we'll get to how flat window glass were produced in a moment. But just the evolution in window glass production. So the old Roman glass pieces, they weren't clear yet. They were of different thickness. They had to put glass pieces together and then use the forming and pressing techniques until the advent of the blowpipe, where they can, glass windows could now be blown, bullseye, or then the moon glasses, much larger pieces of glass. And later that was replaced by the cylinder process, like the medieval Germany, where you blow a cylinder and then you cut it open And then you heat it again, and with the wet wooden block, you iron it out and get a flat glass. And these pictures are from the Lambert's glass workshop in Bavaria. They're still producing around 5,000 different colors by this old process. And that's used for church restoration, cultural heritage, the old windows, and a lot of glass artists order their glass pieces there. The next big changes in glass processing are more technology. So it's going not in glass working anymore, but how to fire the furnaces. So wood furnaces were super important to settle Central Europe, to cut down the wood, charcoal, ash, the plant ash used for glass making, and settlers followed, the villages followed. At some points, so much wood was fired that the first nature reserves were stated so that the rulers had some place to hunt. And in England, the first coal-fired furnaces started, but the coal was so impure that it wasn't good for glass making. Other industries used it first, and glass making really only switched from wood to gas with the regenerative fired furnaces in the 19th century. And that's when industrial glass production started. So yeah, very quickly, the stained window glass windows for normal houses, these large mirrors for palaces, chandeliers, the Venice glass art, and then glass for science, for emerging physics and chemists, glassware and thermometer glass and better telescopes. But they were still all based on the old 7 oxides, the composition of the Egyptians and the Romans. And Fraunhofer, the best telescope at that time, that was inventing a stirring mechanism for glass melting, better homogenization. And glass science only started with Lomonosov around 1750, making his own glasses and new compositions and colors. Harcourt tried in England, but his glass samples weren't good enough to be even characterized. And then only 1882, Schott, Abbe, and Zeiss really started with a new laboratory making new glasses, borate glasses, phosphate glasses. They were making their way through the periodic table. And that's actually, as a PhD student, Eugene Sullivan learned about those borosilicate glasses and then came back to America and applied that at Corning. And so the story of Carl Zeiss, Ernst Abbe, and Otto Schott, that would be worth a whole talk on its own, because they were not just a great mechanic, physicist, and chemist inventing new glass, but they also in Germany, they were the first to have sick leave, pensions, 40-hour weeks, and all kind of social contract with their companies. So they were really fascinating. And with that, I want to, sorry, I was too quick there. I want to stop with this slide. So now we entered the glass age around 5 years ago, according to scientists from Corning. And yeah, this year we have the International Year of Glass. We now do all kinds of glasses in glass ceramics and in communication and optics and biomaterials. And so yeah, there's no time to go there anymore, but any questions I can answer to anything about glass in the last 4,000 years, I will try to do my best. Thank you.
Thank you, Doris. So please feel free to unmute yourself and ask questions or post questions in the chat.
Hi, Doris. It's Garrett. I have a question regarding the history of glass at Alfred. What came first? Somebody asked me this question the other day. They asked me the question of, did Alfred establish a glass program in art or in engineering, or did Corning come first? And what could you place in that timeline?
Frankly, I don't know. I mean, I read the books about the New York State College of Ceramics. And I think by Corning for a long time, they were more in the normal container glass manufacture. Really going into glass science was later. But I wouldn't know the exact numbers. That's something part of this talk is older than me coming to Alfred. So I definitely have to research the modern day history for a sequel of this talk. And I certainly will look into that.
The question from Megan Jones, could you talk more about what defines the 21st century as the glass age?
Well, I don't know if the Corning scientists were just a little bit overconfident in how important their work is, but we certainly have glass in all aspects of our lives without really realizing that, and not just at home with the glassware and the windows, but I mean the screens of the smartphones and the tablets and touch screens and the EpiPens and the communication from here to Europe, that all uses glass fibers. Optics, lasers, there's a lot of glass lasers. Photonics are quicker than electronics, so there is a lot of research in glass as a memory device. And so because it's transparent, you can send the light through it. Now the biomaterials, most of the biomaterials are based on glasses, from toothpaste to bone replacement. Dental veneer is glass ceramics. So there's, I think it touches every aspect of our lives in a way.
There's a comment from Gabby Gustauda in the chat. She says, art and design and engineering started at the same time. 1900, New York State School of Clayworking and Ceramics, then renamed the New York State College of Ceramics in 1932, with two departments, General Technology and Engineering Applied Art. So thank you, Gabby, for that information.
Yeah, I know they started at the same time. I think the real glass work was a little bit later than the ceramic part, and to become an independent chair, but I don't know about the Corning relation.
Laura Johnson says, you mentioned that it's very difficult to get iron residues out of early glass, which is why the items turned out greenish. How did they manage to get the impurities out to make it clear?
There are two ways. One way is you are lucky and have a sand that doesn't have impurities. And I mean, that's what all the glass makers try. And that's why sand for cement production is getting rare. When the costs are increasing, it doesn't affect glass making because we always went for the higher quality, more expensive sand anyway. And so we don't compete with those people. And so the Egyptians, by using mineral toner, and the Romans, and then having high purity sands, they could be sure that they would get high quality glass. There actually was a PhD student from, I think, Belgium, who was traveling the Mediterranean coast, sampling all the beaches, and then comparing that with Roman recipes of glass composition to find which one was the best sand used by the Romans at that time. That's a nice PhD work. Later, it's the potash process. So they were actually washing the ash, because if you had quartz crystal, you had a really pure raw material, but you got the manganese and the iron through the plant ash from the burnt trees. And they were actually dissolving this, and the hydroxide would precipitate, and then they would sieve off the clear solution on top and would burn that down. They evaporate all the water, and then they're left with a clear sodium and potassium oxides for glass melting. And that's how the Venetians got the clear crystal glass. And you often have at the same workshop in Europe, they made the clear glass of higher quality, and they still had the green, unwashed, natural green glass, which they sold for cheaper and simpler design, actually. So either you cleared afterwards, which is not very time consuming, or you happen to have really high purity raw materials.
There's a question from Megan Jones. Would you say the rise of glass science in the 1700s occurred around the same time as that of ceramics science?
But I would say Lomonosov in 17th, 18th century. I mean, he was doing everything. He was one of those universal scientists. And at that time, everyone else was just doing the same old glass thing. And And also, if you had your own little glass company, you were secretive about your own recipes and how you made the glass. You weren't sharing that with anyone. So you weren't sharing that with scientists either. And glass science only started in the 19th century. And hardcore, I mean, that was a pastor who tried those little glass melts, but that wasn't yet a movement. That wasn't anywhere made into anything that could be sold or was usable. So glass science was very, very late. As I said, only the last 200 years. In the 17th century and that time around, it was all about technology, making larger pieces, making less, having less bubbles, having better quality. And they still used exactly the same composition, or very close to the same composition as everyone else did the 2000 years before them.
Doris, I have a question. Back in, say, Roman times, were glass artifacts as valuable as, say, things made of gold and silver and precious stones?
Well, at least today, looking back, they aren't, because it's much easier getting a Roman glass sample to study than a gold Roman glass sample, a golden Roman sample to study. So you know today from the ease from the Greek government to get a permit to study pieces is on how valuable they're deemed today. And we get the glass pieces from Mycenaean time, we don't get the gold pieces. So there's a hierarchy in the materials. I think the glass pieces, the Roman glass pieces, they were more every day than older times, but I don't know about gold and silver. I don't know the exact difference in value there. And just coming back to the chat, Gabby just said, so we beat Corning with our glass science program before they really started venturing into glass science, while they were still only doing container glasses.
We have time for one more question if anyone wants to ask anything. Matthew Seven, could there have been some chemistry that was not understood at the time that contributed to some of the ancient glass making techniques that seemed superstitious?
Well, I'm sure there was a lot they didn't understand. There's still something we don't understand. And sometimes we think we expect a certain outcome, and then it's all other because a fly fell into the crucible and reduced the transition metal ion, the color is different, and all kinds of things are happening. So I don't know if, I haven't heard anything that the moon phase would be somehow playing a role. But I mean, even today, if you work glass, there are certain trees that are better for working a glass and for doing the flattening of the cylinders, for example. So that it makes a difference if the glass, if the tree grew in a clay area or somewhere with more quartz. And so the smoothness of the wood depends on where it grew. And that's secrets glass makers told their family. And that's why you don't read a lot of the old recipes, because it was kind of secret. But yeah, I think there's a lot of just random things happening, which why the glass works this day and not the other day. That's the best I can say to that.
And there's a comment from David Gottfried in the chat. Things that people may not have understood, I guess: barometric pressure, temperature, humidity, microclimates, saltier sweat from the glassmaker. Okay, I assume David's talking about things that affected the process that perhaps people didn't fully understand.
Yeah, and they didn't have a thermometer. They didn't know what temperature in the glass furnace they had. So sometimes the whole annealing layer was too high, and then all the glasses lost the form they had, and you had to start new. So, I mean, that was just experience to get to exactly the same temperature again and again. But then you take a different wood, it burns differently. Some wood, and it depends on the age and the type of the wood, and the dryness, and so many things. Yeah, there were a lot of random parameters in the old times.
Well, Doris, thank you for a very interesting, accessible talk. And it was great that I was able to follow it through all the equations. So thank you very much. And good way to start off the International Year of Glass. All right. So thank you, everyone, and hope to see you next week at next week's Berggrund Forum, Laurie, and tonight at Jenny Sorkin's talk as well.